In this lesson, we're looking at exponential growth and decay, so we're going to learn how to solve problems using the formulas for exponential growth and decay, as well as analyze some graphs involving growth and decay. So let's go ahead and get into the lesson. Recall from our previous lesson or just prior knowledge that an exponential function is written in the form of f of x is equal to a times b to the x. I'm circling it right here. And remember, b is the number that has the exponent. So now when we're looking at exponential growth and decay, if b is greater than 1, the function is a growth and it is increasing. So looking at this graph at the bottom, we have this blue graph. That is a growth. That graph goes up from left to right because remember we read from left to right, so it is going up from left to right. And notice that b is 2, and so 2 is greater than 1, so that is a growth. If b is in between 0 and 1, the function is of course a decay, and it is increasing or decreasing. So looking at this graph, the red graph at the bottom here, that graph falls from left to right, and if you take note of b is 1/2. It is between 0 and 1, so that is a graph of exponential decay. Exponential growth occurs when a quantity exponentially increases over time. And we have the formula here for exponential growth. A is the new amount of the result. P is the principal or the initial or the starting amount. R is your rate, and that has to be in decimal form, and T is time. Sometimes you'll see an X right here for T, but just note that that exponent there would be your time. And again, we have this graph here to show you exponential growth. That graph goes up from left to right. So now let's solve some problems involving exponential growth. So let's take a look at this first example here. It says the original value of an investment is $1,400 and the value increases by 9% each year. Use the exponential growth function to find the value of the investment after 25 years. So of course we know this is a growth because it says increases by 9% each year. And so let's label everything. So what is our P or our principal or our initial amount or starting amount? The original value, it says, is $1,400, so that would be our P. The value increases by 9% each year, so that is our rate. So our rate is 9%, but remember it should be a decimal. So to change this to a decimal, we're simply going to move the decimal 2 places to the left. So it would be 0.09. All right, so that is our rate. The time is 25 years. So I'm just going to plug it in. A is equal to 1,400 times 1 plus 0.09 raised to the 25th power. And from that point, it's just plugging it into the calculator. Simplifying it a little more. All right, so 1.09 to the 25th power, of course, using order of operations, so we use exponents first. So putting that in the calculator, 1.09, and I'm using this calculator here. Hopefully you can see it. So my exponent key has the, I'm trying to get it in the camera there. The exponent key has the y to the x, so right here. And I can't get it in there. Yeah, it has the y to the x, so I'm going to hit that, and then my exponent. And so that gives me 8.62, and it keeps going. So I'm just going to keep that in my calculator, then multiply that by 1,400. And that equals $12,072. And since we're talking about money, I'm rounding it to the nearest 100, so that would be 31. So $12,072.31 would be my answer to this problem here. So let's try one more exponential growth problem together before I have you try some on your own. In 1985, there were 285 cell phone subscribers in Mayfield. The number of subscribers increased 75% per year after 1985. We want to find the number of subscribers in 2008. So first, let's look for our principal amount. That would be the 285, so that would be our starting point. So we could say that P is 285. Next, our rate. Our rate is 75% each year. So moving that decimal over 1, 2, that would be 0.75 or just 0.75 for our rate. And our time is, so it doesn't give us the exact time, but it says 1985 to 2008. So just subtracting or counting the amount of years between 1985 and 2008, that would be 23 years. All right. So now we're just going to plug it in to our formula at the top here. So A is equal to 285 times 1 plus 0.75 raised to the 23rd power. So just plugging that in and simplifying it, that'll be 1.75. So 1.75 raised to the 23rd power, and again I'm using that key that has the y to the x right here, and I get calculator's messing up, 1.75 raised to the 23rd power, and then I multiply that by 285. So keeping everything in my calculator, I get a lot. So I get 110,845,988 subscribers. And why did I round to the nearest whole number? So in this case, because we're finding a number of subscribers or people, we round to the nearest whole number because you can't have a percentage of a person. Whereas before, I think I was looking at money. So we round it to the nearest 100. So just depending on what the problem is asking for, that should tell you how you should round. All right, so I have two examples I would like for you to try on your own. So go ahead and pause the video and try these two examples on your own. So go ahead and pause the video and check your answers. Hopefully you got them correct. If not, keep the video paused a little longer to analyze my work here a little more. Now we're looking at exponential decay, and that occurs when a quantity exponentially, of course, decreases over time. We have the formula here. The only difference is we have a minus where we had a plus before. So exponential growth has a plus r, exponential decay has a minus r. And we have a graph here. Remember that graph falls from left to right, so that would be an example of exponential decay. So let's try some problems. I'm going to do one with you, and I'm going to have you try one on your own. So let's take a look at example 5 here. It says the value of a car is $18,000 and depreciates at a rate of 12% per year. So that depreciates tells us that that rate is decreasing, and our rate is 12%. So let's just label everything. Our P, our principal or initial amount, is $18,000. The rate is 12%. So remember, we have to change that 12% to a decimal. So decimals understood to be at the end. I'm going to move it to the left 2 places. So my rate is 0.12, and my time is 10 years. And let's go ahead and just put P. That is 18,000. So plugging it in, that equals 18,000, which is P, times 1 minus 0.12, and raised to the 10th power because T is time, so 10 years. 18,000, simplifying that, 1 minus 0.12 is 0.88, raised to the 10th. So I'm going to put that in my calculator first. So 0.88 raised to the 10th power equals, I get 0.27, and the numbers keep going, and then I multiply that times 18,000, and I get $5,013, and I'm rounding to the nearest 100 because I'm talking about money here. So that's 0.017. So this is my answer I got here. Having a hard time angling this calculator, but it's probably backwards for you. But anyway, so that would be 0.02. So $5,013.02. This car depreciates after 10 years. All right, so the next problem I'm going to have you try on your own. All right, I would like for you to try this problem on your own, so go ahead and pause the video and try this problem on your own. All right, so you should have gotten 19,152 people. If not, go ahead and pause the video and analyze my work here a little more, but hopefully you got it correct. Let's take a look at example 7 here. We want to analyze this graph as well as the word problem here. It says, consider the exponential function f of x is equal to 500 times 1.05 to the x power, which models the amount of money in Tyler's savings account, where x represents the number of years since Tyler invested the money. The graph of the function is shown below. So it says x represents the amount of years, so that would be our time here. So sometimes we'll see x for the time, but remember that the exponent is the time for exponential growth and decay. So let's answer some of these questions here, or all of the questions. So part A, it says, is the money in the account growing or decaying? That is growing. How do we know? From the graph. The graph increases from left to right. How do you know? From the function. That is because b is greater than 1. In this case, b is 1.05. So that is greater than 1, and so that is a growth. Part B, what is the rate or growth or decay? What does this mean in context? So rate is 1.05, and since we know that it is a growth, that would mean that it was originally 0.05, because in the formula it tells us to add the 1. And so changing that back to percentage, moving a decimal 2 places to the right, so we can say our rate is 5%. And that means that every year the amount of money in Tyler's savings account increases by 5%. Let's look at part C. What does the 500 represent? That is the initial amount. How do we know that from the graph? Because that is our y-intercept, which means that at 0 years there were $500 in the account. So looking at this graph here, that is our y-intercept. So that is our initial amount. Now, how do you know that from the function? Well, because a is equal to 500. Because remember, exponential functions, our a is first here, so a times b. That is 500. So that is our initial amount. So let's go ahead and analyze this graph here a little bit more. All right, so part D for this problem, it says consider f of 8 is equal to 738, and I'm just going to underline this number here. While this is the correct value when we plug in 8 for x, so if we were to plug in 8 here, is it appropriate to answer in this context? So think about it. We're talking about money here. So when you're referring to money, how do you round? You round to the nearest 100th or nearest 100th. So the amount after 8 years would be $738.73. So this would not be appropriate because we're talking about money, so we'll round it to the nearest 100th. And the last part of this problem, what would be an appropriate domain for the function when modeling the situation? It would be x is equal to 0. So remember your domain, we look at our x value or our x-axis. And it would be greater than 0 because since opening an account, it will start at 0 time and continuously until that account is closed. So again, domain, the time would start at 0 and it will stay open until the account is closed continuously. All right, so the last problem I would like for you to try on your own. Go ahead and pause the video and try this problem on your own. So go ahead and check your answers here. It's a lot of words, so go ahead and just pause the video and check your answers. And if you did not get them correct, just analyze the graph and the problem and the answers here a little bit more. All right, we reached the end of our lesson. I want to thank you for learning with me. Some related videos are constructing exponential functions as well as transformations of exponential functions. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.